Good day. This is the Professor, CBMD PhD, and today's Wednesday, July 12th, 2023. It is 5:21 and 8 seconds, a.m. Eastern Standard Time, and today's research, Age of the Universe. So let's jump to it here. Reinventing cosmology. New research puts age of the universe at 26.7, not 13.7 billion years. Date July 11, 2023. Source: University of Ottawa. Our universe can be twice as old as current estimates, according to a new study that challenges the dominant cosmological model and sheds new light on the so-called impossible early galaxy problem. For years, astronomers and physicists have calculated the age of our universe by measuring the time elapsed since the Big Bang and by studying the oldest stars based on the redshift of light coming from distant galaxies. In 2021, thanks to new techniques and advances in technology, the age of our universe was thus estimated at 13.797 billion years using the lambda CDM concordance model. However, many scientists have been puzzled by the existence of stars like the Methuselah that appear to be older than the estimated age of our universe, and by the discovery of early galaxies, an advanced state of evolution made possible by the James Webb Space Telescope. These galaxies, existing a mere 300 billion years or so after the Big Bang, appear to have a level of maturity and mass typically associated with billions of years of cosmic evolution. Furthermore, they are surprisingly small in size, adding another layer of mystery to the equation. Astronomers propose that the redshift of light from distant galaxies is due to the gradual loss of energy by photons over vast cosmic distances. However, it would seem to conflict with observations. Yet, astronomers found that by allowing this theory to coexist with the expanding universe, it becomes possible to reinterpret the redshift as a hybrid phenomenon rather than purely due to expansion. In addition, astronomers introduced the idea of evolving coupling constants. As hypothesized, coupling constants are fundamental physical constants that govern the interactions between particles. According to the astronomers, these constants might have varied over time by allowing them to evolve. The time frame for the formation of early galaxies observed by the Webb telescope at high redshifts can be extended from a few hundred million years to several billion years. This provides a more feasible explanation for the advanced level of development and mass observed in these ancient galaxies. Moreover, astronomers suggest that the traditional interpretation of the cosmological constant, which represents dark energy responsible for the accelerating expansion of the universe, needs revision. Instead, astronomers propose a constant that accounts for the evolution of the coupling constants. This modification in the cosmological model helps address the puzzle of the small galaxies observed in the early universe, allowing for more accurate observations. And this is a Professor of Astronomy, Space Technology, Advanced Physics, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.